going to talk about automatic generation of values. This is the second video I'm making on this concept. In case if you have missed my previous video, I'll provide it in the cards. You can watch the video. So in this video, I'm going to talk about another method of generating values. Okay, so in Postgres there are two data types called serial and BIGSERIAL. So these are the data types or mechanisms that can be used to generate the automatic values for a given column. Serial is 32-bit integer and this is a 64-bit integer. So you need to carefully choose this data types, depends on your data that is going to be inserted into the table, right? So how do we use these data types to generate? Let's take an example. So I have prepared a couple of scripts already. So let us drop this table as a cleanup. And then this is very simple, like in my table I have a column called ID. You don't need to mention any specific data type called integer, big integer, numeric, nothing like that. Simply provide a keyword called serial, and this is a primary key. So that's all. And there is another column called name. So let's create this table. So created the table, and I have also prepared a couple of insert scripts for demo purpose. Let's insert, I'm inserting 4 records. So let's see how this will behave. So the behavior of serial data type is completely in control of Postgres engine. So it means assigning the values of this particular column is going to be decided by Postgres, and it always starts with 1. Okay, and you cannot change that to start from something else that we want. So ideally for all of our 4 records, the IDs would have been assigned as 1, 2, 3, 4, right? So let's verify that. There you go, 1, 2, 3, 4, right? Now, so is there any way that the sequence values are skipped? Yes, there is a scenario in which Postgres can skip your serial values. So you need to be very careful when you are choosing this particular data type, in case if you have a requirement to not to miss any sequence numbers. For example, let's say after 4th record, and if you insert a next record, in any circumstances the record ID value should be 5. So if you have such requirements, I strongly recommend to not to use the serial data type, because in some scenarios when the transaction is rolled back, the PostgreSQL will skip the sequence number and it will go for the next sequence number. So this may not be accepted in some of the very strict requirements of serial numbers or your record numbers, like for example in financial domain. So where the your invoice number or receipt number have to follow a proper sequence without any missing, because that may be very important for audit purpose. Now let's see a simple demo where the serial numbers can be skipped by Postgres, right? So this is a simple anonymous block. So those who are not aware of anonymous block, please wait for some time. I'll make a separate videos on anonymous blocks and how it works with a lot of examples. Okay, so for now just concentrate that only the insert script here. So I'm trying to insert a record and then immediately I'm rolling back. Okay, so now we have 4 records, right? Now let's try to insert and I'm rolling back. So as a result, I should not have any new record. Yes, there is no new record. Now let's insert this record. So now let's go back and see what exactly happened. So now if you see, there is a gap between 4 and 6. So that's the problem when a transaction is rolled back. Okay, so you need to remember this important point. Now coming to the BIGSERIAL, it's very simple. So I will just create the table again with a different name. The only difference here is the data type name, that's all. BIGSERIAL, finished, right? So now let's try to insert the couple of records into it. Okay, now we have inserted 4 records. Let's query the table and see the results. That's all. The behavior is going to be the same. The only advantage of BigSerial is you will get the variety of, the size is very big, which is a 64-bit integer, right? That's all from this video. Thank you for watching.